And share the screen.
And share the screen.
The right one.
This one?
Yeah, this one.
We are good?
Okay, we're trying one more time. Welcome back to the afternoon session. It's time for IMG, and Jesus will chair it for the rest. Jesus.
Okay, thanks, Jenny. So we are starting the IMG slot. We have two presentations from Norbert and Stephanie. Stephanie is not around. I'm going to check with her by email if she's going to join. So we will start with the presentation by Norbert first. That is called Systematic Quality of Experience Assessment of Multi-User VR, Task, Taxonomy, Performance, and Delay Sensitivity. So please, Norbert.
Okay, thank you. So I'm Norbert Barczyk, and I would like to present the research we performed with my colleagues about the cooperative VR. Okay, I see. Wait a moment. Can you move the slide? Okay. No, I don't know. No. Okay, fine. So the motivation was basically the increasing interest in VR as a medium to cooperate in a long distance, to share the 3D space. And as we know that the nature of the task is really significant in case of quality of experience. For example, for social XR, the nature of the task really differs the acceptance level. And we wanted to understand why people communicate, because we wanted to make it as simple as possible. We need to understand the purpose, we need to understand what people do, we need to understand why people do that, to understand how their performance, their subjective opinion can be affected. And to do so, we based on the psychological model of McGrath. It proposed the 8 categories of different tasks, which can be performed in multi-user scenarios. And we also wanted to take a consideration on survival task. So this is the McGrath model. As we can see, there are 8 categories: planning, performance, competitive, mixed motive, cognitive conflict, decision-making, intellective, and creativity. We decided to cover 5 of these tasks in our research because other 3 were quite difficult to implement in VR, because, for example, the mixed motive task demands the internal objections, internal opinions, so it would be difficult to develop it in VR. So I would like to describe briefly 2 of these tasks, and if you are interested in the rest, we can. I will show it in our on our lab tour. We wanted this task to be as easy as possible. We wanted them to be replicable, because we didn't want the we wanted to have a full control on this task, and we also wanted to it to be engaging for people. So the communication should be active between participants. And the main gameplay based on inserting the correct cube to the box. As we can see on this slide, there are 16 cubes on the table, and participants cooperate together, communicate to find the correct answer. I want to briefly describe two of them. So, intellectual task. This one was the task where one user received the encoded word, and the other user received the substitution pairs, and they need to communicate to find the correct letter. And then they insert it into the box. In the cognitive conflict task, users were supposed to find the cube, but there were 16 cubes on the table, and each cube contains one letter and one number. But the trick was that participants see different information on these cubes. For example, one participant, as you can see, one participant see only the numbers, and the other see only the letters, and they are provided with a hint, for example, 4 and B, and they need to communicate to find out which cube contains both the letter B and the number 4. We performed our study on 24 participants, most with no or little prior VR experience. We evaluated the standard quality of experience score graded from 1 to 5. And this is the system flow. For example, I can describe it more briefly. After start, we set a delay from 0 to 1.5 seconds with the step of 300 milliseconds. Then users cooperate together to find the correct answer, and they need to find 4 cubes. And after 4 cubes, we ask them about the quality rate. And then if we cover all these delays, then we end the scenario. This is the quality rating table we use, a typical one from 1 to 5. And according to the objective metrics, we can see that there is a difference between these tasks. We compared the mean number of interactions. The interactions mean that one of the users grabbed the cube, and we compared the mean time to correct answer. And we also normalize these metrics with a 0 millisecond scenario, the best one. And what is also really important that for the planning task, for the meantime to correct cube, we can see that there is a decreasing time to find the correct cube with the increasing delay. So it's quite strange, but in our opinion, we think that maybe users still improved their strategy during the game, but it requires further investigation. And these are the subjective metrics. Two of the most affected tasks were cognitive conflict and the performance task, with a drop from the best and the worst scenario. The drop was about 2 points from the 1 to 5 most score. And the competitive, intellectual, and planning tasks were also affected, but not as much as these two. Okay, so to sum up, results showed that the performance task was the most affected. the task had high correlation between delay and perceived quality. The advantage of this task versus the survival task is that we can easily replicate this. We can, for example, configure the words we want to use. We use the word of 4 letters, but we can use more. We can easily apply the number of cubes. We can easily change the things that are presented on these cubes. For example, if we want to use different shapes or something like this. And other tasks also have the high correlation between perceived quality and the performance. What also interesting is that this research can provide interesting information on the communication behavior, on the behavior analysis of VR communication. And in future experiments, we plan to include all 8 tasks. We need to find out how to develop these 3 tasks in the best way to match this psychological theory. We also want to make more detailed investigation on only the user behavior in this task. And that's all. Thank you.
If there's no questions, I just have a comment that I think we really should learn from this experience if we want really go towards like LLMs, anything that is interactive, yeah, because it really shows in 1301 the standard is really well described how the interactive test should be done. It is there in the context of telecommunication and audios and the speech communication especially. But in general, in my opinion, this is really key. Like we can really see how important it was that people were able to do the task 4 times before they even score. And then again 4 times the same task, but the task is the same, but still they really feel the difference in the conditions and etc. So thinking about something like that is really crucial to be able to do a correct experiment. So in my opinion, this is very, very difficult to find a nice task that fits. We already kind of crumble on that, like we are not sure where to put our task on the circle of different tasks because it's not so obvious. We thought, for example, for a long time that we have a performance task well done, but now we are not so sure, etc. So it needs really go and thought and trying, but this is something that we really need.
And what I want to add, we had a problem with testing the VR cooperation. For example, in our pre-test, we found out that users basically score only the 5 because they had no prior experience. They didn't know how the good and bad quality look like in VR. So that was a big problem. So I didn't mention it, but we also had, before the testing session, basically this is the flow of the testing session. We can see the 6 different delays, but there was also the training session with 0 and 1.5 seconds. And then we show the users what are the critical scenarios. And then we discussed with them what they saw. For example, it was quite funny, but with these cubes, when you grab the cubes and move it in the other place, in about 1.5 second delay, 1.2 second, you can see something like the synchronization. You move cubes from one place to another, and it goes back to the first place. So it was funny that for us, it was obvious that there is the synchronization, but users were like, oh my God, I didn't press the button correctly. I don't know why, but users just take the system faults as their own faults. So basically, that was another insight from this study, that users basically don't know how VR works, and they have it is really difficult for them to identify what is the system problem, what is in this case the network problem, and what is their own problem with, the gameplay, finding the correct way to use the controller or something like this. So that's why we had the training and the testing session.
So, so in line with the recommendation, we had these 4 types of tasks, right? One was more communication, like survival. Then we had these object-based Lego blocks, and then we had some for exploration, and the one of charade, right? So this is more in line with, or probably a mix of the survival task with the block-based, right? Because there is interaction with objects.
Yeah, but to some extent, the block base only is also a good explanation, because we did this experiment with Margaret in Boulder, and we did sessions without audio, and people were able to do it.
Uh-huh.
So it's really like the interaction within the virtual space more test than anything else.
And do you plan any modifications on the tasks? I mean, because you are planning to do more tests, probably something that we can try to replicate.
Psychological theory is from 1984,
Uh-huh.
but it's quite, interesting, and it describes just combine the previous, insight on user collaboration, and the author tried to combine this insight and make one model to analyze.
Because maybe we can replicate that in other labs, like UPM, for example. We can do it also and have more people doing the same
Yeah,
thing.
so definitely we would be super happy to share it and explain. Well, it's not very difficult to run, actually.
We have it standalone on the Quest, for example, so we don't need any specific computer for that. We just need one external computer, because on this computer we had an external server. We also applied the delay on this computer. We also applied and we also had the GC server for the voice communication. So, for example, if you run it standalone on the MetaQuest, you will need to find out how to, run the GC communicator on your Quest. So we basically use one laptop for that to just communicate between users. But yeah, it's quite easy to, run this solution.
And just one curiosity, if you go to the graphs, to the charts that you have for the performance, when you have a lot of delay, they were faster to find the correct object. Can you go to the next, to the charts, no? these ones, no? In the performance, so you have more delay. But you have this decreasing, no? In that is.
This is the mean number of interactions
Uh-huh.
of two, and this is a delay. Delays were exactly the same in all of these scenarios. Yeah, but you can see that with the increasing delay, you can see the huge, really strong increase of mean number of interactions. So basically, users were like, because the okay, so I showed only two tasks, but the performance task was just a cognitive responsive task where users use different information, but they are limited with the time amount. So basically, they were like almost, time is going to finish, and there is time to shuffle cube to, just be on time.
So in that one there, the mean time to the correct cube, no? And in the performance task, when you have 1.5 seconds of delay, they are faster to find the correct cube.
Yeah, but you see that the confidence interval is very huge. So this is just a random effect.
Yeah, okay.
Yeah, it's not
Because
like
later in the questionnaires, they rated quite low the quality of experience when the delay was very
Yeah.
high. No? Okay, okay.
As I mentioned, we had 24 participants, and yeah, it would be really good in...
And Norbert, we cannot hear you.
Sorry.
Okay, so we had 24 participants, and yeah, it will be really good to improve the number of participants, for example, to get more stable results.
Thank you. Yeah, very interesting study. I still am a bit struggling with your, because I mean, there's a kind of double use of the word performance, right? Because you have an objective metric which is called performance, and you have a scenario which you call performance, right? That causes a bit of a confusion to the listener, I think. So this is the metric confusion, obviously, performance, obviously, right? So I am still, also I try to grasp it from the paper, which I try to get through briefly now in parallel, but I couldn't still not completely understand the metric performance, right? So it means that the number of touching of the object increases with delay.
Yeah, number of touching of objects increase, yes. And why the name performance? Because we wanted to match this model exactly. And from the original model, you can see that this kind of task was basically called a performance. So we wanted to make it to match, the words. Like performance means the
but that is the term you use for the task, right?
Yeah.
So, but now I'm about to understand the objective metrics, right? If you go back to your results slide there.
Yeah.
So, and there this is really is it a number or is it a rate? I mean, do you understand what I mean? So is it? I don't quite understand. I mean, if it is really the sheer number, for example, right? I mean, did you, I have to reread the study to fully understand, maybe you said it, was the duration that people were able to run the experiment always the same? Was it limited in time? Or was it that they were to complete the task in a way, right? And then you calculated performance? Because it will, I mean, I mean, intuitively, I would have thought, okay, so performance in this sense here, in this objective metric, it could be, okay, I'm less effective because I cannot communicate very well because of the delay, right? And so I need more trials touching something, and there are misunderstandings. So there's an increase of touching just by the annoyance due to the delay. Could be, right? But that's not so clearly understandable from, I mean, I didn't understand it fully from your presentation nor the paper, unfortunately. So I think that would be very interesting to better understand, right? So is it, but I didn't fully read the paper also, so maybe
Okay.
it's on me. So is it due to this, okay, lack of communication means I'm kind of struggling and I'm touching this in order to find agreement, and then I'm touching that in order to find agreement and so on? Or is this maybe a linear effect because you didn't limit the time spent on each individual trial and people just had more time to touch things because the delay was there, right? And so due to the delay, I mean, if I am, if I calculate how many turns you have, I mean, it would be now very interesting to know how many turns did you have. Then you multiply it by the delay, right? And by 2, so to speak, right? And then you can basically calculate the increased time it actually even just took to communicate, assuming you have the same kind of communication underlying this, which also will change, obviously, right? So, but these factors, that would be interesting to better understand in maybe future analyses of your data, right? How did this come about, this effect, right? I mean, just this metric performance there, yeah?
Okay.
I would be interested.
Yeah, what I want to add about this, the time in performance, we wanted all the pairs of users to somehow finish the task. So we decided to start with 15 seconds to finish, to find the correct cubes. But if they fail, we add more 2 seconds. So then in the second try, they had 17 seconds, then 19. And if they find the correct cube, finally they need to find, because you can infinitely increase the amount of time. Then we go back to the 15 seconds. So basically, the idea was to let all the users, even with no experience, even the older users, to finish the task. Because it's quite obvious that younger participants had better performance because they were like playing games and something like this.
Okay, but here on the y-axis, the actual performance count is not somehow normalized by the duration of the conversation or something like this. No, so that's the absolute number.
It's normalized to the 0 millisecond scenario. So, for example, in 0 millisecond scenario, they had some average number of interactions. And in, for example, 1 millisecond, 1 second scenario, they had on average 7.5 more interactions to find the correct truth. Okay. It's just normalized with the best case scenario.
I understand. Okay, thank you. Yeah. Okay, and so it's not like a rate or anything.
No,
okay,
no. It's just the difference between the best scenario and the actual scenario shown on this X-plot.
Yeah. Okay, and then the second comment I have, I would be a bit careful with the statement that this is by which you were stating which is the best scenario, so to speak, right? I mean, definitely for the task of connecting delay experience of network conditions with very much delay. I mean, 1.5 seconds is very much, right? Maybe you know the work that we did. I didn't check the references on speech quality under delay, right? We did some quite extensive work on this some time ago, and there we it is very clear that there are certain scenarios, just audio only scenarios, that is in this case, right? Which I find this super valid. Don't get me wrong, right? Or very very interesting, but be just careful that for that particular task, it is actually the right thing to do, right? Because there are in real life. I mean, what is the best kind of scenario? It is the best scenario, sure, for kind of it's like a grill, right? I mean, if you don't capture the effect that you are introducing at the network side or at the service side, right, with the scenario, because the scenario just doesn't care about it, right, then obviously you're kind of blind to find any effect, right? And here, obviously, you found a scenario which has that effect. In our audio-only case, it was these short conversation. Sorry, these timed kind of random number exchange task, right? You may be aware of it. I'm not sure. And that task was found to be specifically delay selective, let's say, right? But I would never say that this is a very natural task. Nobody would do this in real life. And similarly here, it's a very specific game you have played as a subject, right? Yeah. Which in this way you would not normally do in real life, right? Totally fine for your study, but I just would be careful to say that that is the best scenario. Yes, for that particular task, right, to find the effect of delay. But how generalizable it is, I'm not sure. I may point you to the last thing, because it's speech communication you're talking about here. There is an addition to the so-called E model, right, that we have introduced some time ago in G.107, which actually takes the interactivity of the task into consideration in the prediction model for opinion for pure audio-only speech quality, right? And so that's maybe also something interesting to look into. Maybe you can define an interactivity description of your conversations, right, that you can use for additional complementary description of your task. Yeah, thank you.
Yeah. Yeah, for interactivity, maybe the questionnaire from the NASA TLX scenario, there is something like this with the cognitive load, analyzing the cognitive load, analyzing the...
No. What I meant is really a conversation analysis-based description of what is interactivity, right? So how many turns per time, maybe even cleaned by the delay you introduce, do you get, right? Okay. And something like this, I mean, I would really look into this. It's super interesting data you have, and I think there's quite a lot of information you can still squeeze out of it, which you haven't done yet.
Okay, thanks.
Well, thank you very much. Maybe I will do some clearance from my side. So first of all, just to be super clear, every pair has to solve the task to go further. So in theory, this could take like 15 seconds for one pair and 2 seconds for another pair. This is one thing. The second thing is that those two metrics, so this is the number of interactions, and then with delay, the number of interactions increases, mostly because the cubes start to be kind of dropped. So you try to move the cube, but it jumps back on the same place, because like you move it so fast that server didn't really realize that it was moved, and then it did some update and like ignore your movement. And this is like a completely different thing. It's a little bit like with packet loss and video transmission all time ago. So whatever packet loss is, how the effect is visible on the screen depends on how the decoder handles it. And this is a problem, yeah, because here is the same. Yeah, we can do different things the moment there is a discrepancy between my state of the game and the state of the game on the server side, and we can do different things. Yeah, but this is one of the solution, and in our implementation, this was the solution. And then performance is a specific task where if you fail, you actually do the task again, but it will be counted as the same. So that is why for performance we have this huge increase in number of touches, because simply people have to start again. Now, from the conversation point of view, I doubt that we can extract a lot of out of that, because at least running it in Boulder, which is specific because we run it mostly with the anti-IS employees, some of them with military background, and they simply didn't speak at all. Like, they've got two scenarios where they have audio on and audio off, so they can do the task without audio at all. It's possible, but lots of people didn't use audio by definition. Like, it was easier for them. You can, since you are looking for a cube, so you can rise the cube up and then just kind of wave with it, and then the second person wave to you, okay, this is correct one, etc. Yeah? You don't have to communicate by words. So this is something that will limit any analysis on based on audio, because it will depend on the strategy. Yeah? If the strategy was to communicate, use audio communication, then maybe we could get some information. But if not, then we won't. And then finally, I fully agree that the results that we have are valid for this game, not else. But what we hope is to cover the circle that was at the beginning. Can you come back to the circle? Like in theory, from psychological point of view, if we have tasks that are fitting within the circle, there is a more chances to generalize to similar tasks within the circle. Of course, still I completely agree with you, just to be clear, that it's not easy to say if they are generalized, yeah? But in theory, this what should happen, or we hope for that, and definitely much more research is needed to really get there. Yeah? But this is the idea behind. Like, let's divide them to different categories and then do something there. Okay. Any other comments? No questions online. Okay.
So also probably we will have a demo, right?
Yeah. I would like to present the demo. Because the second presentation is not.
Yeah. Stefan is here. We can do the second presentation. We will have a short presentation on the next step of IMG, and I think we will still have some time in the slot. So probably we can go and see the demo of Norbert. Okay, thank you, Norbert. So I think Stephanie is online already. Stephanie?
Can you hear me?
Yes.
And probably you can see me now. Hi.
And we can see you, yes.
Okay, perfect. Then I will try to see if it works sharing my screen. Can you see my screen?
Not yet.
Okay, let me try again.
Now we can see your PowerPoint, not the presentation.
Okay, great. So now you will be able to probably see my presentation.
Now we see your slides, yes.
Okay, perfect, great. So I'm happy that I was able to come today, and I'm sure, I'm sorry if I didn't manage to make it on time. I'm currently in the United Kingdom, and I had like a misunderstanding of the time difference. So, but I'm happy that now I'm finally here, and I am excited to share some of the research that I did when I was affiliated with RWTH Aachen in Germany, and we did this work in collaboration with TU Ilmenau and also some researchers from the University of Glasgow. I'm currently at Birmingham City University in the UK, and today I will present a little bit of our research on the impact of partner representation and task on the communication experience. And I hope that it's working. Yeah, great. So video conferencing enables communication across distances. However, it constrains the visualization of nonverbal cues. Here, avatar and robot-mediated communication promise to enhance the communication experience. On the one side, avatars or human-controlled digital representations can provide realistic human appearances, and they allow for nonverbal behavior or for visualizing some nonverbal behavior. Avatars or avatar-mediated communication also enables some feelings or evokes some feelings of co-presence, which can be defined as the feeling of being in the company of others. On the other side, telepresence robots or remotely controlled systems, they provide physical embodiment. They can also allow to see some nonverbal behavior, either through the screen or through the robot actually executing some nonverbal behavior. It has also been found that telepresence robots also can enable this feeling of co-presence. Telepresence robots are robots that have video conferencing capabilities, but are on a mobile platform. For some reason, okay, great. So we decided to compare it to face-to-face communication, and as face-to-face communication has been long been the paramount for communication clarity and for communication fidelity among partners. But also the communication varies depending on the communication partner and actually the communicative goal. So we consider three different scenarios or three different goals. The first one is conversation, just a free conversation or a guided conversation where the main goal is actually to exchange information with the conversational partner. And here seeing nonverbal cues can actually evoke rapport in both of the communication of the people who are communicating. On the other side, negotiation, one of the goals in communication or in negotiations is to reach an agreement. Here, actually seeing nonverbal cues allows to reach an agreement faster than not being able to see this nonverbal behavior, and also not seeing nonverbal behavior can lead to misunderstanding. Then referential communication, we consider this type of communication as an example of collaboration where one of the goals is to establish mutual understanding. What we see here in this short clip is a task where the conversational partner has one image, abstract image, that are tangrams, and the other person needs to find that image based on verbal descriptions. Great. So our main motivation was to compare or see what avatar and robot mediated communication can do, and if the context, the goal of and communicative goal can elicit attention to different nonverbal behaviors. Here our goal was to compare robot and avatar to face and understand what are the perceptual differences when representing a conversational partner using a robot or an avatar and how that compares to face. We also wanted to know how the different communicative goals influence the perception of the communicative experience and the conversational partner. So in a study, and I hope that you can hear the video at some point. So we conducted a study that had a split plot design, and on the one hand, we had as our within variable the type of representation of the conversational partner, and here we had the partner represented as in face-to-face. So they were, as you saw the first clips, the person was co-located in the same room, and they had, for example, a conversation. Again, we had these different tasks. So the conversation partner was represented in face-to-face using an augmented reality avatar, which is the one you see right now. And it is a similar avatar and a photorealistic similar avatar. And we also had the conversational partner represented on the screen of a robot. Our between variable was the type of communication, and we used this guided conversation, a negotiation task, and for that we used a survival task. And we got this task from one of the ITU recommendations. So inspired on that, we used this for to explore negotiation, and that is what you see here. People had a different set of items displayed in front of them on the physical world, and they needed to agree which items will help them survive in a hypothetical accident. Then we had the referential communication with movement. Again, here the goal was to establish mutual understanding. And as you saw there was this person walking in the room. And I will.
To the
Can you hear the audio from the video?
Skiing. That was really great. Really nice winter.
But
yes?
you can only do this
We
when you have a
can,
car.
yes.
Okay.
Maybe also food would be good. There's also some food.
Oh, the AMI ratio. Yeah, that's nice. That would be nice. I think there's a lot of a lot of nutrition inside, so it lasts long. The lead dancer who's doing a pirouette with stretched leg, like in a 90-degree corner, and spreading out his.
Is over there?
Yes, correct. But the semester
So
before we have like
that
a
is how
wonderful winter,
the
and
different
it was
tasks when a
after
person
lectures,
was
I
talking
was
with
always
an
going
avatar
to
look like.
the Rennsteig and going skiing.
So I will first mute this so I can talk a little bit. Some measures that we collected were self-reported measures of co-presence, closeness, perceived communication satisfaction, and as one of our main questions was actually nonverbal behavior, we also collected information of the self-reported attention to behavioral cues, and we also collected written feedback about the whole experience of talking with another person using an avatar and a telepresence robot. In these experiments, we recruited 54 participants, and the sample size was determined using G-Power. And as you can see in all the videos, the Confederate was, we used the Confederate as the conversation partner. So there was this person that was interacting with all these people and was being represented through an avatar or a robot. And now I will enable the audio here.
Isn't it maybe, I don't know about these bags, but I know from the envelope, with the little plastic window in it, you know?
Yeah, that can be, like, this is normal paper.
Yeah, it can be in the paper trash,
yeah,
right?
Because it's made out of paper. It's not not made out of. But the first thing what came in my mind in the desert, it's getting really cold at night.
Yes, maybe we should take the coat.
I guess, yeah, that's a good idea. To have a coat will be like, oh, I see a sad rabbit sitting in the corner.
Do you mean this one?
Yes, that's right. Absolutely.
Some of our results, as expected, were that actually in our collected measures of copresence and communication satisfaction and also closeness, the face-to-face or having or interacting with a person in the physical world in person actually led to the higher copresence, communication satisfaction, and closeness compared to avatar or robot-mediated communication. However, we found nuances in the reported attention to nonverbal behavior. For example, we found that in terms of gesture, people report that pay more attention to gestures of in face-to-face, but also in the avatar condition compared to a robot. And similarly, for body, where again, people report pay more attention to the avatar, similarly to face-to-face compared to the robot. Now, in terms of facial expressions, we found that, again, face-to-face, people report paying more attention to the facial expressions of a person in face-to-face compared to robot or avatar-mediated communication, but they also report paying more attention to the facial expressions on the screen of the robot compared to the avatar. We also found that main effect of the type of task where in terms of facial expressions, the conversation, people reported paying more attention to the conversation, to the other person's facial expression during conversation and negotiation compared to referential communication. And finally, we also found a two-way interaction derived from the main effects, that during the negotiation task, people reported paying more attention to the facial expressions on the screen of the robot and in face-to-face compared to the avatar. And in terms of referential communication, people reported paying more attention to the facial expressions in face-to-face compared to mediated communication, either using a robot or an avatar. And yes, we also carried out some thematic analysis. And for that, we found some, we analyzed and determined some themes. Their main theme, one of the themes is about ambivalent visibility of mediated nonverbal behavior. Here, some participants, for example, mentioned that during the negotiation task, that it is very strange not to see any real expression or emotions on the face. And regarding the telepresence robot, some participants mentioned during the referential communication that they liked actually that the other person was able to easily point when using the robot. As you saw, there was a projector mounted on the telepresence robot, and we used the projector and a green dot to emulate deictic gestures. A second theme actually has to do with the feeling of presence. One participant here mentioned during referential communication that the other person was not only available on the video, but they were also there with the physical presence of the robot. Regarding avatar-mediated communication, during negotiation, a person mentioned that they felt like the person was present with them, and that the other person who was remotely located was also seeing the same as the other person. Another theme has to do with the avatar that does not feel natural, and they felt that there was something creepy. Here, some participant mentioned that it feels so weird to communicate with someone who seems like coming out of a 3D game, and that was mentioned during the negotiation task. Another theme has to do again with the avatar and with the avatar's physical resemblance to the Confederate. I mentioned that that the avatar was a photorealistic similar avatar to the Confederate. However, some participants mentioned that the avatar was resembling the real person, and they found it quite good. However, some other people felt that actually it was not resembling the real person. We also had some comments regarding the ergonomics of the HMD, and they felt that the HMD was very uncomfortable and noisy, and for that we use the, as you saw in the videos, we use the Vario device. Finally, another theme has to do with the robot, and here people mentioned that using a robot to communicate actually felt like a video call. But that is exactly one characteristic that some participants actually like. I like that it felt like the video call, but more interactive. The key takeaways from this study, or what we found out with this, is that avatars and robots can evoke similar levels of presence and communication satisfaction, but they actually do not reach face-to-face levels. Here we found also nuances in the attention to nonverbal behavior. Here we found focus aversion, so people were either not focusing or they reported not focusing on nonverbal behaviors that were ambiguous or that they not met the face-to-face levels of realism and behavior fidelity. For example, we saw this when there was more focus on the facial expressions on the screen of a telepresence robot and more focus on the gestures and body movements of the avatar. Here we also found that regarding the tasks, that similar to face-to-face, there's a focus on facial expressions during conversation and negotiation. These also lead us to ask ourselves, actually, if should mediated communication provide, or if some area of research should still try to pursue mediated communication in terms that it should provide similar to face-to-face experiences. So we consider it maybe with avatar and robot mediated communication face-to-face or go beyond trying to evoke a similar experience and focus on the strengths of avatars and robots. For example, avatars can provide visual or they are a visual and behavioral twin that enable presence in multiple places at the same time. So we can consider there's one area of research that investigates details that is a digital twin of a person that is in different places at the same time, or who is available when the person is not. And regarding telepresence robots, we can capitalize on actually the physicality of telepresence robots and add other characteristics that go beyond communication. For example, they can manipulate the physical world and provide assistance. And with that is the last part of my presentation. So I'm happy to reply to any questions. And if you are interested in this piece of research, you can scan this QR code and access our paper. Great. Thank you very much.
Thank you, Stephanie. Questions? Both from here and online. The illusion, please.
Thank you very much for excellent work. Very, very interesting. I'm not sure if you checked the time to do the task. I guess it was much faster face-to-face than robotic, or the avatars version, just because of the glitches in the communication.
That's an excellent question. Yeah. So we actually purposefully capped every task at 4 minutes. So every task lasted 4 minutes. During the conversation, they were talking for 4 minutes with all the different representations of the communication partner. Also, the negotiation task, it was performed in 4 minutes, regardless of the medium that they were using.
Okay,
So we didn't leave it open that people can talk for how long they want or perform the task for how long they want. We purposefully capped it to 4 minutes.
I understand. But for me, this is what I found really interesting in, I think it's 1310 recommendation, where they do a task that has an end. Of course, this could be a problem here, but a task with an end, and people do it face to face, and then they do it with some different conditions, network conditions, and then you can compare. Like in our experiment, we couldn't do it because one people see numbers, another person see letters on the same cubes. We cannot do it physically. But if we have chance to do it physically, in my opinion, this comparison between physical doing a task and then whatever terms of the communication doing the same or well similar, not of course not identical task, but a very similar task. In my opinion, those are very, very interesting because like this would give us a clue. If it takes like twice as much, it's not surprising that people complain. Yeah, if it takes the same amount of time, but still people complain, then it's like a little bit different story.
Yes, that's an interesting point. And I see that, for example, we did not take a look at these other network impairment factors. And maybe if you could see on the video, for example, that's something that we improved for on our next experiment, that was when the robot was moving around and pointing, it took a bit of time. So people were aware that, okay, now I need to wait for the robot to move and then point. And that was different for face-to-face and, of course, with avatar-mediated communication. But we didn't take a closer look. But that per se is an interesting question. And yes, definitely further, it guarantees further investigation.
More questions. Questions online? I have one. I may. No, but it's from previous comments. So. Okay. More on the, maybe I missed it. It's more on the technical part. So how was the avatar generated or captured?
Yes, for that we used some software called Character Creator, and then we generated this avatar based on an image, a picture of the person, of the Confederate. After the software generated the we modified, for example, the hair texture. We worked on the hair texture, and we also modified a little bit of the body proportions. Then we did actually some pilot testing with a few people, and we showed them the person either through a picture or when the person was available or they knew the person. We asked them if they think that actually this avatar looks like the person. We did that prior to the experiment, and we actually invested quite some time in trying to make it as close as possible. But of course, there's limitations that we had at that time with this specific software, which was Character Creator.
Okay, and how was it animated? So, because it was like interactive communication between the real person and the avatar, right? But behind the avatar, there was a real person.
Yes. So for that, we actually use trackers. So the person, for these experiments, the person was wearing trackers on the hands, are on the feet, and with the Vario headset. So we had all these points of tracking information that then were translated to the avatar movements.
Okay, so the trackers were coming from the same,
yes.
I mean, the Vario equipment.
The Vario, yes, and then we use 5 trackers attached, 2 to the hand and 2 to the feet.
Okay. And last curiosity, when you had this video with the robot, interaction with the robot, the guy was wearing also glasses, right?
Yes, yes. We also collected eye tracking data because
Okay.
we wanted to actually compare the self-reported measures that where people reported that they were paying attention to, either the facial expressions or the body movements or the gestures. But we actually wanted to know how that compares to the real information captured with the eye tracker. So we had the eye tracking information or gaze data from the Vario, but we also had it in when the person was interacting with the robot, and also in face to face they were wearing an eye tracker device. We also have this is a work that has been already submitted, but it's not out yet.
Okay.
But that's
And
it's an
also,
interesting question.
which glasses were these eye trackers? It's you remember the
Yes.
ones?
So they are actually called Ergoneers. It's from a German company,
Okay.
and yeah, they are the
Okay.
Ergoneers.
Cool. Thank you. More questions? Yeah. Pablo has a question.
And thank you. Now I can have a better idea of who is asking me. Now I know where the voice is coming and can maybe connect the voice
Sorry,
to
I was
it.
not.
Yeah, thank you. Thank you for that. That's
Uh, Hi, this is Pablo Perez. Um, I'm curious about the measurements that you're showing on the slide 9. So
mhm.
gestures, body movements, facial expressions. This
Yes.
is like eye tracking results, or can you?
No, that was
No.
from the self-reported measures. We use a questionnaire for that. The questionnaire we use for that, it's coming from an author called Roth et al. I think I can go back to that slide quickly. Well, not so quick. Where I have some, yes, it's here. Is when some things are missing, the quality of interpersonal communication in social virtual reality. So they provide a tool where you actually ask the person where they were looking at. And that is the self-reported measure that we use. Again,
Okay.
the other behavioral real eye tracking information, it's part of a second publication that is currently under review.
Okay. And did you even qualitatively observe how? Oh, I mean, we've done similar experiments using immersive telepresence. So instead of a robot, something similar to the robot, but with 360 video in real time. And we typically observe something similar to your robot thing, which is that in spatial relevant information or tasks, like the one with your tangrams, people really don't look too much to the robot or to the other person. So people are more focused on the environment and not really on the face-to-face communication. So this comes more from our observation. So I was
Mhm.
basically, my question is, if you were kind of looking at the experiment and the self-reported information looks similar to what you have qualitatively seen from outside on how people behave.
Especially during referential communication, because there was movement, so people were actually either looking at the items that they have on hand. So the person who was guessing, for example, they were looking at the piece of paper that they had in front of them, and then at the behavior of the person. So they were, because of the nature of this task, it's more goal driven. So that takes the attention from, for example, the facial. We noticed they were looking at the other person when they had not a particular goal that they had to do. For example, in this guided conversation, they had nothing but the other person represented through different through an avatar or robot. So there they were really focusing on the other person. But if they have a goal or if they have a task, we also observed that during the survival task. Again, they were looking at the items in front of them, not at the other person. But here we wanted to know really what type of nonverbal behavior do they look at when there is nothing environmental wise that they can look at. So often in face-to-face communication, people pay attention to the face, especially the eyes and the mouth. We wanted to know if they would also focus similarly when they are with an avatar. Do they focus on the eyes and the mouth? Or maybe because of the specific characteristics of this avatar that we use, because it didn't include face tracking, maybe because the limited mobility of some micro expressions in the face, for example, maybe they're not looking at the face, maybe they're focusing on other artifacts of the avatar, like the hair, for example. I'm not sure if I went too wide and I actually didn't reply to your question, or did I?
No, you did. Thank you. Thank you very much. And a small thing that you have probably already mentioned, but so it was within subject comparison. So they all did
It
all
was a
the
split plot.
conditions.
It was a split plot design. So it was a within and between subjects design. So what our within variable was the type of representation of the conversational partner. So face-to-face, robot, and avatar. So every participant experienced this. But we had different groups for the conversation task. So a group of people performed only conversation. Another group of people performed only the negotiation task or using the survival via the survival task. And another group of people, they performed this referential communication. So they didn't do this. Not all our participants did all three tasks, but all our participants experienced these three different representations of the conversational partner.
Thanks a lot. Very, very interesting study. Thank you very much.
More questions? Not from here, not from line. So thank you, Stephanie. Very interesting work. Thank you.
Thank you very much. And keep on enjoying the other talks.
Thank you. And so we will move to the last presentation. Maybe I need help here. Camille? I have uploaded my presentation. But not sure how I can share it, you know. So now you should. Can you hear us? Now it works. Okay. And can you see the slides too?
Yes, we can see them. Thank you.
Perfect. Thank you. Okay. So last presentation of IMG slot, just a brief update on the plans or what we were expected to do and we didn't do from the last BQuack meeting. I will try to push from now on. So as you may know from previous meetings, we did this test plan between 13 labs evaluating different immersive communication systems, and we got this ITU-T recommendation published in January in its final form. That is ITU TP1321, called Interactive Test Methods for Subjective Assessment of Extended Reality Communication. That is available for everyone. And we have a lot of data to analyze, a lot of things still that can be done. So we have some plans on working on a joint paper to describe the whole process, not the final results of each experiment, but more the whole process that brought us to this recommendation. And more on a communication magazine style. And we plan to start working on this, after the last BQuack meeting, I was not able to push this, so we will start to work on it from now on. And also we wanted to create like 2 working groups, depending on the people that are active or interested in any of these 2 activities. One will be to analyze the results from the questionnaires that we have from all the test labs, and another one will be more analyzing the behavioral data that we have from these test labs. Again, this was planned to be started or at least launched in January, but we were not able to do this, so we will try to do this from now. I have just sent an email before to the people participating in the tests to indicate if they are interested in any of these 2 activities to create these 2 working groups. In the first working group, we will analyze the results from the questionnaires. We have a lot of questions, a lot of questionnaires analyzing different aspects of the immersive communication from different tasks, systems, etc. So we have some ideas, not super specific ones, but we want to identify relevant questions. One of the problems that we had in all the tests is that at the end we ended up with a lot of questions that made the test quite a bit tiring. So some ideas, some analysis per lab, something that has probably already been done by the labs since we have already some publications from individual labs. Then go to analysis per group of labs. So some labs were grouped by tasks. They all perform the same tasks, or they are all using the same system, etc. And then probably analyze for all labs. The outcome will be joint publication, can be scientific or can be just a BQuack report. And the action points from now on is to identify disinterested people. We are on it, so I got some responses. And we are planning to share this data from the questionnaires in an anonymous way, so probably we don't have much problems, and maybe we can use BQuack for that to publish this data set within BQuack and the new resources that we have. The second activity will be the analyzing the behavioral data. So we captured audio, we captured movements, we captured eye tracking, we captured a lot of things, and we would like to know what we can do with this. This is a lot of work, and the first problem we are facing is how to share this data even among the labs that have participated in the test. No? This is something more sensitive and something that we will handle within the working group. We have already started to identify the interested people on this, and I remember when we had this IMG BQuack meeting in CWI, we met all the labs there, and we were discussing that sharing the data can be a problem. And analyzing how to analyze the data is kind of difficult task or significant enough to maybe address it as an ITU work item. And other possible future joint activities, we also talked about this in the last BQuack meeting in December, One thing that we have that is already there is that, or one thing that there is not out there is a recommendation from ITU on quality assessment of 3D objects. This means meshes, point clouds, and even can be like Gaussian splats. Nowadays, especially probably focused on certain type of objects, can be dynamic, static, can be human, can be cultural heritage objects, etc. And what we have identified is that we have already done a lot of tests, people within BQuake, but not like in a joint activity, but people from CWI, from UPM, from Rome, from Nantes. So we have done a lot of tests already with different methodologies. This is just a survey that Amar from Nantes did, and what in 2024 there are already a lot of studies using 2D screens, 3D screen, HMDs, single stimulus, double stimulus, etc. So there are already a lot of studies there from people that are around VQuake, and probably we can take advantage of this. And considering other works from other people, also works that are done in MPEG and JPEG, probably we can work on providing some guidelines and recommendations on this. Now that probably digital humans or digital representations of avatars is getting more and more let's say, a hot topic, and this can be a good thing to address here. It can also attract people from other communities like compression or avatar creation, so probably it's a good thing to start thinking on. And also in line with the discussion that we addressed yesterday, to address also AI or Gen AI type of content creation and etc. So the first step will be to improve this survey and see if what has been already done can be beneficial, or we need to do some more tests, and then probably even go into a work item within ITU or within BQuake, etc. I think tomorrow there is an ITU informal discussion on possible joint activities, so maybe we can also discuss if this makes sense there. So I think that's all from my side. Yeah, this means that that's all. So comments or questions?
Thanks, Jesus. A couple of thoughts from me. I think overall and strategically working aside or in collaboration with other groups is beneficial for us. I believe that every time that we try to go, say, separate way, it didn't always work out. So if I have to say, give my own suggestion would be to do alliance with other groups that are addressing not necessarily the same, but similar problems. And of course, MPEG and JPEG are very well-known groups that I would highly, agree or suggest. I would also add AO Media and the VVM work there, which is essentially to a large extent, when you mention other communities compression, of course, MPEG and JPEG are, compression, but I would encourage, and that's one of the things we can discuss about the liaison statements we can make to that effect. Because I believe what the compression, specifically point cloud and volumetric media, are lacking are subjective evaluation. Of course, objective metrics are always important. That's one. The other thing that I would like the group, and I trust primarily you and the group to come to us and say is, how in the past we have always reflected about popularity or lack of popularity of certain applications that are related to video. I'll bring only one example, the 3D TV work, right, that we all know was I can say, very popular and then lost popularity. I would like us to reflect not whether the current, XR, AR, VR field is popular, but what exactly is the most popular application. Because you can be very generic and cover, or you can be a little bit more specific. Just like we talked about yesterday for, Shogai, maybe we need a very solid but application-driven, use case to cluster and then build upon it. These are my two thoughts here. But other than that, again, there is full faith on the group that are working on this field for a long time to guide us on the next direction.
Thank you, Yanis. We will take that into account, and for sure, this is why we have probably to focus on which type, if we go for this way, on which type of objects, if we are focusing like human representation for applications like volumetric video conferencing where humans are represented digitally or things like that. No? So we have to reduce the scope, if not, it will be too broad, yes. More questions or comments?
I've got just one small comment. I'm just wondering, because if we focus on use cases that are used right now, then probably there's no tremendous problems with quality there because people are using it, yeah? So, but maybe people don't use, I don't know, multi-person trainings because this multi-person doesn't work, as was shown in the previous presentation, yeah? Like how many glitches is the moment you try to cooperate with avatar. So maybe there is an idea to, especially if we could kind of measure the gap between the real life and interaction and then within VR interaction and try to think about, can we really reduce this gap, or maybe we cannot. It's just impossible because of the technical limitations of the technology, yeah?
Okay, thanks. So maybe elaborating a bit on this. So especially the quality of assessment of 3D objects. If we think about that, I think it's more about the representation rather than the use case. Because what I feel I need to probably catch up with JPEG and MPEG and all those guys, but my impression is that most of these organizations are based their evaluation of their 3D codecs on 2D screens, basically on some projections of a standardized way, which is a simple way to evaluate things, which is very stable, which is what MPEG likes because of a number of reasons that have been already discussed here. And there's not really a method for a subjective method which makes sense, let's say, for evaluate 3D objects that has been widely tested. So, and this is a long missing thing. I mean, a missing thing for that has been there forever, let's say. So it's not a new thing, but maybe now could be an interesting task to address now that the technology. So maybe the use case is not as popular in the short term as other like Gen AI things, but probably 3D representation of the world in a way or another is a valid use case that can be addressed, and are definitely contributions. So thinking out loud, maybe what we might miss before starting something like a joint recommendation or joint work could be some presentations from the state of the art. So maybe gathering or inviting for the next plenary or for any other. So if we are to start this work item, maybe it could be a good idea to try to gather some of the people who have already done some of these studies to present the studies in a VCOG meeting. And this could be a starting point with some specific ideas to discuss, let's say.
Sounds good. Sounds a good idea to address in the next meeting, yes.
Also, if you have the people in a meeting, then they might be willing to just keep contributing.
The place to talk about it. More comments? No more comments or questions, so we are sharp in the schedule. We go to the break. Magic coincidence.
Okay, so thank you for keeping us sharp on time. It's time for our last break of the day, which I believe is...
What with visiting the lab?
Oh, we have the lab.
Yeah, there's like, okay, so there are like two ideas. We can either go... Before you close the session, I want to tell you. Sorry, just before we close the session, I have just one more comment for all of us. There is a new activity within ITU Study Group 12, probably in Q14, but maybe it will be in Q15, which is somehow related to this work, and I just wanted to mention it. We had suggested some kind of object-oriented modeling of the quality of social XR services, right? So where basically, and it actually quite nicely matches the idea of, okay, I'm judging 3D objects, but in this case, basically representations of persons rather than, I mean, considering the social XR context, right? But it's also very close to video conferencing in a way, right? And now the idea is that we would first target a first kind of drop of this project, standardization project idea, which targets video conferencing quality modeling, right? And yeah, so anyone who may be interested in this, I would cordially invite to at least dial in for the upcoming Study Group 12 meeting, right? There's a dedicated session for that in question 14, and maybe it will land in question 15, which is actually for the interactive quality evaluation, the target question. But we will be discussing that at the meeting and announce it appropriately. Yeah. Thank you. And sorry for saying that after you were closing the session, Johannes.
Okay, so if I may, there are like two things. One is that we could go for the short walk and see our quality of experience lab, which is just one floor down. And we can do this today, or we can also make it like tomorrow when probably we have like more time. And we also would like to bring you to the roof of our building, where it's also quite interesting. We can even have a picture there, or at least we can see the view from the above. And we actually have the lab there as well. It's not the QA lab, but it's the antenna lab. But so there are like two options. We can do this today or tomorrow. I don't know when do we have more time.
My thoughts are, being respectful to the guests who are online, I suggest we take a break now. I see that we have three papers from Emmy Mech, right, following up, which probably will not fill the whole hour and a half. Therefore, how about if we try the tour after we finish MEHF, hopefully early? What do you say? Can we do that? Is it too late? No. Okay. So, all right, decision. We adjourn for now. We resume on the hour, 26 minutes from now. And then depending how we go, we finish early and we take the tour. Hi everyone, we are all back, I hope, or some are coming back from the break. It's now time for MEHF. MEHF. And we have chaired by Mikolai. So Mikolai, whenever you're ready, the floor is yours.
I think like I'm ready, but I don't see so many faces in the room, so maybe
this will change drastically very, very soon. Let me go out.
Yes, if you go out and ask, this will change.
So they will come in or they will never come in.
There is some technical problem, but so maybe I can start meanwhile. Okay, discussing what do we have here at this session. So basically, we've planned 3 presentations that, if they really take that much time as the authors promised, it will not take more than around 1 hour. So maybe we'll have something like a half an hour after this session for some extra activities, like, for example, the lab trip, but we'll see. Okay, so we have like 3 presentations, and the first one is Michał Wierzchoń from the Jagiellonian University, and he's like getting ready because there are some technical issues. And so then we have Natalia Bartusiak, who is the PhD student of Lucian. And I understand the last one is Alex Rake. Yes, with the. Okay, okay, but this is someone from your team, right? So I understand he's online, right? Or he's both.
Yes, I am.
Okay, perfect, great. If everyone is happy with the order, I think we can start. Unless have you solved the problems? Okay. So now I'll stop sharing, and you can start sharing, and there you go.
Okay. Just to check whether it's working or not. Can you see online my presentation as well? And was it visible here? Yeah. So great. Yes, we made it. Hello, everyone. Thanks for the invite. Lucian, Mikołaj as well. It's already, I counted something like 8 years we are collaborating each other. So this started a bit. It started a bit by accident, because like one of the colleagues from here just come to my lab. I'm a psychologist. I'm doing psychophysics. So something that is basically very related to what you are working on, but for some reasons the researchers are like rarely communicating between each other. So I'm here just basically to tell you what we are working on, like in the recent years, and with like a 3 examples, because I think that this kind of the presentations in between the disciplines are supposed to be like relatively kind of straightforward. So I would just basically like to show you like a 3 examples of the studies that I think might be informative for what you are doing. It might help to improve like the measurement in a context that you're interested. One of them will be also kind of surprise for Lucian because it's brand new. so hopefully that will be of interest also of yours. So as said, it's all started with this project that has been granted to Lucian already some time ago, and we've met a year or
before, just like discussing about possible of collaboration. So what I'm doing in one of many things that we are doing in my lab, which is consciousness lab, we are actually mainly doing right now the neuroimaging. So we are even privileged to have got our own MRI. That is for research purpose only. So we are doing MRI, EEG, transcranial magnetic stimulation, like a lot of stuff. So this is like a part of the thing that we are doing. But in the context of the measurement, so the thing that is like the closest to the quality of experience that I'm talking about today, we are basically trying to develop the answer to the methods to answer two questions. Like first of them is like how well we are aware of the thing that we are actually seeing right now. Like so how visible the thing is, how hearable the thing that you are hearing is, and this is typically made with the subjective judgment. That is actually kind of analogical to the quality of experience metrics that you are typically using. And then maybe like less obviously in relation of what you're interested, we are especially interested on what influence these judgments except of the quality of the stimulus itself. Because we are doing consciousness study, and the consciousness is about what your subjective experience different from the objective external world, right? So in a sense, like our main focus is your, contaminating variable, so to speak, right? Because like we know, and we've got like a very large number of examples showing that what we actually present to the participants is quite sometimes very different from what they actually see, right? We have like a multiple examples that I don't have like a details into go right now, and we are investigating like the features that may, cause this difference. So of those, like the most obvious things are like predictions, like expectations, so whatever people like kind of expect to see that influence their perception quite massively. Then we've got like the whole line of showing like what people are doing, it's actually influenced their subjective judgment, previous knowledge, and like many other things. But again, this is not really of interest here, but just to give you the broader context. So how we are doing, and starting with the take-home messages to kind of focus on what I would like to pass you through, is that we are actually trying to answer these questions, also developing the measures, which are again like very similar to the quality of experience measures, and we've got like a lot of discussions that are kind of similar to what you've done. We've heard about the bias, we've heard about the sensitivity, about like many things that you are like investigating to the same extent that we are investigating, but there are some differences. And now, of course, focus today on the differences, on the three examples I said at the beginning. So one will be the influence of the reaction time. And this is something that we were discussing with Lucian already for some time, and I think that it was even kind of passed to the community in the context of the recommendation. So I'll follow up on that a bit, why the action time is sometimes interesting. Then I'll focus on the individual differences, so how different we are in the judgments, but also how different we are from ourselves, like over the time, for example. And this last thing, especially in the context of something that's kind of, it's called the slips of attention. So like how our attention fluctuates over the time, which is of course like kind of yet another contaminating variable in the context of our studies. How we are doing. So we've got like this large list of methods that we are typically applying to verify how people are, to what extent people are aware of the visually of the thing that they're seeing, for example. So this starts with like obvious choices, like for example, confidence, like to what extent they're confident on what they see, right? We've got like the variants of it, not going to too much details, but post-decision wagering is basically based on betting. So this is like a confidence, but for those who do not really understand what the confidence is. So this is, for example, the type of the measure that is used in the animal studies, or this is used in studies with the children, right? Then we've got like a more emotional version of it, but then something that is like most close to what we are interested today, namely various versions of perceptual awareness scale. And this is a measure that is a very relevant and I think to some extent analogical to the quality of experience metrics. Namely, this is like a 4-point scale that express like the clarity of seeing on a scale from I see nothing to I saw a glimpse, I saw something almost clearly, and I saw something clearly, right? There are like variants of the scale, and there's like a whole discussion, for example, in which version the scale should be provided. So we've got, for example, a paper already for some time ago that we're comparing a version in which we've got the points to the version that we've got like the dimension in which we are just like marking the response, and showed how this way that you are responding is actually influencing the judgment itself. How the studies that we are doing typically look like. So this is like the quite old examples from over like 10 years right now. So this is like a typical paradigm in which we are, just to show you the analogy of what you're typically working on. So we've got like the fixation point, then we've got the presentation of the stimuli that varies in the vividness or like the timing of the presentation. So basically we typically apply some manipulation that is aimed to make it like more or less visible. So either short presentation versus long presentation, or like low contrast versus high contrast. In a sense, that these are also parameters that you manipulate quite often. And then, and here starts like the first quite important difference. We typically ask about like a objective state of this feature. So for example, like here, the task is just to recognize whether this is the male or the female face, and then we first ask people whether the male is that the face is male or female, and then we ask them to judge how confident they are in whether it was the male or the female face, or how clear they saw that it was like the female and the male face. And what is interesting is that actually this male or female face could be like on average responded even when people are not like really aware of what was presented there, right? So they can perform by above the chance because of different reasons, typically somehow related to implicit processing. That doesn't go into the details again, but so what we are interesting is that we've got this measure that is basically showing, the accuracy of the performance of the task that is based on the detection of the actual stimuli, and then, and this is the important part, we can use this accuracy as a validation for the subjective measure. So we've got like a basically model that allows us to validate the scale, not developing this validation based of the judgments themselves, like as typically Lucian is doing in the context of his group, but our task is in a sense simpler, right? Because we can just basically validate it, and then also of course see when this I think to be expected relation in between the objective task performance, namely detection whether it was male or female face, and subjective judgment falls out, right? Okay, so this is how it looks like, and this also, as said, help us to compare in between the scales, actually in the context of the two main features. So in our opinion, and for our purpose, the preferred scale should cut like two features. So firstly, it should be sensitive, so it should basically capture like the threshold of the perception as low as possible. So actually here people should be at chance level. So this should be like really the situation when there is like no knowledge, and then they are just basically claiming that they saw nothing. And then the second feature is like exhaustiveness. So basically the number of like various steps that the scale is capturing, right? So the more variability the given scale is capturing, the more exhaustive it is. Like so, it can kind of describe the general variability of the scale to the more extent. Yeah, and this is something that we actually did in the context of those scales that I just presented you before, showing that in this particle task that you saw, namely the one with the female and male faces, the perceptual awareness scale was, for example, like more sensitive than confidence ratings, and also make more exhaustive. Not again very important right now, but just basically to show you how this works more or less. So here is some comparison in between like then the quality of experience that we are measuring and the quality experience as I understood from our collaboration with Lucian is an interest of you. So actually we are starting with a quite a similar approach. So basically we've got some quality manipulations. The only difference is that we are manipulating the different parameter of this quality, right? But then, of course, we are just using subjective measures, and we are interested in threshold, right? The only difference is that we are interested when the change is perceived, because it tells us something on the consciousness, and you are mainly interested in this part of the story when people do not perceive this, only because then it means that you can basically use this model to reduce the requirements for the network transmission. Of course, we evaluate visibility, we evaluate the quality, but they are of course related, and I think that the same kind of ideas and models may vary for those situations. I think what is kind of important here that also in both cases, and I think to some extent it's kind of forbidden or haven't like kind of been discussed in the context of your studies, we share the same problems, namely that basically there are like individual difference in the thresholds in between participants. So basically objectively their perceptual system differs in a way that the same quality of the signal or the same visibility of the system may give totally different subjective judgments. And this is not because like the materials were not enough calibrated, but because like the perceptual system differs in between the participants. Then there is like the individual difference in the judgments themselves, right? So it's, I think, the most obvious in the context of the confidence. Some of us are overconfident. So we tell, especially males, as we know from the study, tells that we are kind of confident of majority of the things, right? And then the underconfidence is also like the individual variable that is, of course, influencing the judgments themselves, right? And it's, again, not related to the stimulation itself. It's related to the way we are using the scales, right? And of course, this applies to the visibility, and I believe that it applies to the quality the judgment to the same extent. And of course, then we've got the bias on both subjective and objective level, and this is of course something that I do not need to, kind of extend more here. But there are also some difference. As I already told, we are just like basically focusing on the difference. You are rather on a lack of the difference. But then we are, as said, we've got this objective performance to validate the accuracy, which I think, and this is something that we kind of discussed with Lucian already a few times, that actually it's very difficult to kind of validate the judgments in your case. Also, the majority of the things that we are doing recently is just basically based on the development of the models that take reaction times into the account. Right now, I think we got something around 15 models that kind of try to describe how the reaction times inform us about like how people make the decisions, what they see, but also how they judge the decisions, right? And starting from this most simplest models that basically tells that if you're just reacting fast, that it means that you're more confident in something, and you do not need to actually, kind of judge this confidence because the reaction time is kind of the proof of your confidence regardless of the task that you're actually using. But also that could be used as a kind of the validation of the correctness of the judgment, right? Because, for example, when you're just like saying that you're confident but you're extremely slow, it means that it is quite probable that this judgment is not comparable to the situation when you're just responding like rapidly as it's supposed to be in a given context, right? Yeah, I think that these are the main points. Yeah, so I've learned from Lutz and Mikołaj already some time ago that this is of interest of the statistical analysis method groups. So here is the reference that I think that this is all relevant. So here I'm saying about these 3 features that I believe that might be of interest for you as said at the very beginning. So first is just indeed, as I told a little bit too early, that the reaction times provide the additional information about the decisional process. So here you've got like this typical model, one of these models that has been built in our field quite recently, that are just like trying to describe how this so-called evidence accumulation happens over the time. So idea being that when you're presented with this face, for example, that I just presented you before, but any other object, like including the one that you're presenting, you are just basically accumulating the evidence for, you know, the task that you're asked to do with a given task, with the given object. So in our case, that was like a decision between whether it is the male or the female face. So you've got these 2 alternatives. Then you are just like collecting the evidence, and of course, when the stimulus is presented like for a longer time and clearly, right, then this evidence takes like really not a lot of time, right, because the situation is quite clear, right? But the more disambiguous situation is, more ambiguous situation is, the longer time it takes, right? Because then you've got some evidence for one, some evidence for the other. So you need to kind of decide, and the longer it takes, the basically the more the sign that the more difficult the task is. Applies. But then what we can say later from this model is that actually this also follows with the subjective judgments, right? So again, when you're just like judging something with the high confidence, this basically means that you should react like much faster compared to the situation when you're unconfident on something. And I believe that it should actually be the same with the quality of experience judgment, and I think that this is like an open question we can check, you know, assuming that we will have some data for that. Of course, you can also, as I told you before, that you can use it for the clearing of the data. So this is, for example, the results of the study that I already showed you, as well, in which you can see that here is a log RT and accuracy of the task performance. So what you can see here, that we've got like a lot of correct responses to the given length of the reaction times, and then we've got this tail in which people just start to make mistakes, right? And of course, if we will average the data, we'll never know about it, right? But if you look into the reaction task at the additional information, you don't even need to use this diffusion models to actually account for what timing's meaning. You can basically say that, for example, those reactions if your tasks are basically not trustful, right? Because it took people like too long to actually respond to that. The second thing is like an individual difference. So what we know is that we differ in the thresholds, right? And what I think is kind of typical is that we are just typically trying to change not only like the judgments of the people or affect the judgments of the people, but we also typically try to kind of set up like the comparable conditions for the presentation of the stimulus itself. So I think that this is quite different strategy than what you're doing, because what you're typically doing, then you've got like the different steps of the quality, right? And then you're just comparing these different steps in between the people. That's like the approach that you are typically applying. Because like the threshold of the perception is like it varies very much in between the people. That is actually the strategy that is very difficult to apply in our context. So what we are typically doing, we are applying so-called staircase procedures, right? So this is the example of that, like a very simple one. They are like much more difficult. This is based on the accuracy. So what is here? So here you've got the stimulus intensity, so you can treat it as the quality in your case. So then you've got like when people like correctly respond to what has been presented, the task became more and more difficult, right? And then up to the moment when people then made a mistake. And then if they make a mistake, we are just like making it simpler and simpler and simpler until the point that they are just making correct responses twice in a row then we are just making the task more difficult. And this way we can just basically kind of individually set presentation conditions that are, kind of set to the given participant, right? So I think that this is an interesting approach because it also shows that it's not only also always about like kind of setting the standards for that will apply for the most, but you actually can kind of set the individual quality that is required by the given participant. And the last thing that I want to show you is like this new code that has been developed by the group of my collaborators. Paweł Lenartowicz is the main author of it. So this is basically a code that is taking into account also the other variability that's obviously in the most of those experiments that we are talking about. So each of the experiments that we are talking about consists in a lot of trials, right? So we are just like asking people to respond the same question many, many, many times in a row. In our case, it's even more problematic because we typically ask them at least 300 trials, right? So that, and sometimes in thousands, right? So what this code is doing is actually trying to detect slips of the attention over the performance of the trials. So what we have kind of noticed is that people kind of vary in their performance over the performance of the task, right? So sometimes at the beginning they are focused, right? And they are just try to follow like the instruction, but then obviously they are losing their attention, right? So they become less and less accurate. And then again, they are just like coming back at some point because they are kind of, remind themselves that this is something that, kind of is important for them. And then, they slip attention again and so on and so forth. So this is the code that has been developed especially for this purpose, that is basically analyzing this, accuracy, the objective performance that I was saying about, and, kind of the pattern of the responses. And then is trying to use them to kind of detect the slips of that attention that should not be taken into the account in the of the assessment of the material that is shown, right? We are just right now developing this code also to assess for the subjective rating, so I think that this will be then directly applicable to your cortex, right? That's the zoom up of how it looks like. Yeah, so this is like the conclusion. So hopefully I convince you that these are at least these 3 groups of things that might be kind of applicable in your context. So thanks for the attention. This is like the group of the people I'm working on here and the Jagiellonian. And of course, I'm happy to take questions if there are any. Yep. Yeah, it was below 30 minutes, so it should.
Not really a question, a comment. I'm very happy with your presentation because I think, at least speaking for myself and this group, we can directly, I think, align and associate. And I think that, so that, I also have a strong background in compression, right? So there is a compression community, and actually tonight, is it, or tomorrow, that Matthias will be coming in. But the bottom line is that the compression community, to a large extent, does not understand the topics that you brought up. So that's why I really consider us to be sort of the bridge between the psycho-visual perception. And these principles are very important for especially the young generation who are presenting here to always keep in mind. The practical question I have more for the group: which of these learnings can we fold into our either standards, statistical analysis, or otherwise? Because I believe there is so much synergy that it definitely deserves further, bonding and strengthening. But again, thank you very much. At least to me, it was very, very useful.
Thanks. Appreciate it. Kamil?
So yeah, I think the first research question that we could have is if we know how to find the differences in perception on this level that Michał is doing, would be to test it if it's actually influenced the JND and ACR-based experiments. So if this could be like your perceptual differences would actually be influential on our tests, yeah? And then if it's the factor, then we should add it to the standards to control it, yeah? But it's not that obvious if it will be, because the difference is, as I understand it, we use here people to judge the systems, not necessarily to judge people and their perception. Yeah. So if we would like to include that, we should test it. Yeah.
Yeah. I think that the most obvious example is this timing, right?
Yes.
Because
yes,
that's something that we are just like, because you typically even collect this data, right? You've got the data about like how much time people take to react to.
We should get if we don't already have. It was
Yeah.
the first shock.
Yeah. 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 Yeah, and
we cannot hear.
Yep.
Apologies. I just commented that indeed the reaction time is one of the most, from what I saw, definitive, right? And cheaper to obtain. We just need to be very systematic about always logging it and making it an integral part of the data that we collect when we do subjective testing.
Mm-hmm.
And sorry about that. We need to all use the microphone for our remote participants.
Yeah, I believe that this was written to the last P900.
Yep. I think you added it, right?
Yeah, we added that the time should be measured. Well, the other things we would need to add those stimulus that are similar to yours, yeah, so that we know what is the correct answer. And do you think it makes any sense? Like, let's say we've got 160 questions, yeah, let's say the PVSs as we call it, and then would it make any sense to add the, let's say, each 20 a similar stimuli that you are showing? So something very short, just answer the,
No worries. No worries, no worries.
Can you mute the?
So everything is okay. I think this was
the beauty of the online presentations. That sometimes you can take part in the other discussion.
The question is, would those, let's say, in 10 more questions like that would make any sense, or you really need a series to get any conclusion?
You need a series, but I think that the question is how else you can validate the, kind of the perception, right? Because it naturally cannot be the same question because it's not at threshold presentation, right? So you don't have like a validation of the same kind, right? But what I'm rather trying to argue is that, it's important to have got other validation, right? Than the quality of the signal itself, right? Because the quality of the signal is then, kind of perceived by the person, right? And it's a very strong assumption that it equals, right? Right? That there need to be some kind of the variability on it, right? And then, of course, this is the huge question that I do not know the answer yet, right? But I think that this is something that I think is worth brainstorming, right? So how you can validate it, right? I think that one of the reasons why we, for example, like kind of got like this group of people who are trying to develop this imaging based methods, right? So brain imaging methods here is precisely that, right? Because this is like the obvious way in which you can basically tell that, how the cognitive system is performing the task, right? Maybe there are other ways of kind of validating, but I think that basically what I'm trying to say is that, we can kind of build this work on the comparison of the scales on the very extent, but it was all based on the assumption that we've got some measurement of the, objective performance of the cognitive system on the given task, right?
Yeah, thank you very much for the interesting talk, and I have been thinking about applying this principle or this model that you presented from psychology, where you have a binary choice and then you accumulate the evidence until you reach a threshold, and then the response comes out left or right, or 0 or 1, or male or female. We, in our experiments here, when we judge image quality, usually we do it on a scale from 1 to 5. So then you have 5 different options, not just 2. But I think you can generalize this model to work with more than 2 steps. But maybe it's easier to for you to explain how we should maybe apply this model for accumulating evidence and coming to a threshold for the decision then for binary tasks that we have for pair comparisons. So often we present 2 images or 2 videos and we're asking, well, do you see a difference, and is there distortion in the second or is it in the first, or in the left or on the right? There, this model applies directly. You know, we are looking at the stimuli and comparing. We go look left, look right, what is the difference? And then when we have seen enough evidence, we say, okay, the left image is the one that has, you know, clear distortions, or it's the one that contains the watermark, like we had to talk about watermarks before. And now, how do you have an idea of how we could, you know, use this model to advance our methodologies? I have thought about this already a couple of years ago, but I couldn't find a good way to, you know, actually make that or apply this to, you know, to enhance the models that or the work that we do. Maybe you have an idea of.
That's a very good question. Thank you for that. Indeed, I think like this just noticeable difference paradigm that you just described is, I think, the easiest way to go in terms of the application of this 2 alternative for choice, you know, drift diffusion model that I showed you, namely like this, you know, kind of accumulation of the evidence. But then basically I would start with applying the same reasoning that stays behind of the studies in this done in this context in psychology. So basically I will collect the timing information, right, for like the decision making in between these 2 alternatives. Then I'll collect the subjective rating on top of it. So like, for example, you're just selecting one of them, right, and then you're just like judging, you know, how clear or how you judge the quality, how bad it is, like whatever else, right? But then you've got like this objective difference and then subjective ratings, right? And then you're just like showing to what extent like this objective detection of the difference it actually influence the judgment, right? Because there's like a very strong assumption that, again, like as soon as people see the difference, it influences their judgment, right? But I think that you can kind of build a lot of things on, you know, comparison between those 2 measures that you're applying in your community, right? But I think, I don't know, you're experts, right? But I think that typically independently, right? Yeah, so I'll just like combine this and add time, and then we'll see what comes out, right? In the way, right? But of course, I think that it could be done much more about it, but then I'll need to think more about it as well.
Thank you for your presentation. When you talk about drop of attention, did you find any way to improve the engagement and so to improve the attention of the observers? Especially in the few projects we heard about before, they were talking also about having engaging tasks so that they could have more meaningful data. So did you also find several factors that can modify this drop of attention or increase engagement?
So because this is like a very low-level task, right, then I think we cannot do much more over what we already tried to do, like over those experiments, namely, you know, kind of reminding about the tasks, you know, also setting up like the trials in which we are just controlling the average performance, and then when they are just dropping massively like below what is expected, then basically we're just like kind of rewarding them and all of this kind of the stuff. But I think the real usage of this method is of a different kind. So actually, basically, it is the fact that this attention will always fluctuate. So whatever else you will do, it will always be there, right? Because this is like a feature of the attention, it's also like the huge individual difference in between us, right? Like we also got like this huge discussion right now about neurodiversity, right? Which shows how many people have got like some different level of the engagement of the attention, and you cannot do much with it, right? Like this is basically the populational factor that is up there, right? So how you can use it is actually you can just basically accept that it is there, right? And then just like use this information about like comparison in between the people. For example, like easiest is just to select which results are meaningful and which are not, right? But more interestingly, and this is something that Pavel is working on right now as well, maybe you can just basically kind of use this mathematically to prove what is like the perfect or like the maximal performance of the given person, right? So in a sense, you know, the attention fluctuates, but what you're interested in is what he is able to kind of perceive at their best, right? Because this is something, you know, that is also like a threshold for you, for example, right? So like on average, they are not seeing the difference, but then when they just like really pay attention, right, then they will notice, right? And this is, of course, something that you try to avoid, right? So I guess, you know, if this could be used this way, then, you know, setting this perfect performance might be like another goal in which this could be used.
Thank you.
Okay.
And a question that came to my mind as I was reflecting. I believe Dietmar presented a couple of times his work about how can we take the stimulus, the visual stimulus, and modify it. We like to call it, for example, contrast stretching, right?
Mm-hmm.
So if you want to detect whether there is or not difference, it's well known from the contrast sensitivity function that if you make it, you know, the contrast higher, you will enhance the differences between two stimuli, right? But you are trying to infer whether something is visible or not by, as I like to call it, by taking a magnifying glass of some sort, right? You could think of other ways where you can take something that is very dark and make it like increase its brightness. You can take a video that's moving very fast and slow it down. Do you have any understanding how the modification of the stimulus for the purposes of enhancing the resolution, allow me to say, of the person affects the perception of the original stimulus? So my question is, if I take two images and I really boost their visibility, and I ask a panel and I get certain answers, can I somehow project back and say, hey, I know for a fact that it is at that threshold that people start seeing the boosted stimuli. Can I infer back what is the visibility of the non-boosted ones based on psychovisual evidence?
To be honest, I'm not aware of the studies that did that, but this, of course, doesn't mean that there were no such studies. I'm not so much interested in like, you know, kind of enhancing the perception again. I know a lot of examples of showing, you know, how the perception is degraded because of like a different features, right? So this is like time, like the slow presentation is a kind of obvious example, for example. So, you know, I think that this is a good question, but I cannot answer it right out of my head, but we'll be happy to, you know, kind of try to think.
There is no like translation mechanism or a transfer of what we see in a enhanced presentation versus what we could have seen in the non-enhanced. Can we translate the findings from one to another in a systematic way that is principled and explained
I think
by
that's
human
really,
perception?
I think it really depends on the type of the enhancement that you're saying, right? Because like on the neural level, for example, right? If you're talking about the enhancement, you're typically talking about the enhancement in terms of like basically intentional amplification, right? And attentional amplification is just basically really depend on you know the level of the cortex that you're basically activating at a given time, right? So I think like for example, like a very different response will be for the contrast manipulation, for example, and very different for the color manipulation, right? So it's in psychology, it's typically described under this call of attentional capturing stimuli, right? And indeed, there's like a lot of work on that. but I'm not at least immediately aware of any, you know, kind of reverse engineering, because for us that will be in essence reverse engineering, right?
Thank you.
Okay, I think.
Okay, are there any questions from the room here or for the remotes? I think Alex has one question. Could you please pass the mic to Alex?
Yes, sorry, a very interesting talk, super. I was unfortunately a little bit distracted towards the end of the discussion, right? So maybe somebody has asked the question already, then please just, you know, stop me from asking it. I was wondering, if you do this time measurement, right? Do you have an idea how we could distinguish between, okay, the response is not reliable, right? Which I think in your case is completely understandable, makes complete sense. But in a quality sense, right, it may just be more complex to, for example, parse the information and really get to a judgment or something like this, right? So there may be other reasons why the response time increases, right? I'm speculating, right? Which are not necessarily a sign of, oh, I cannot believe the task, right? For example, I'm thinking in a typical kind of MOS distribution, right? If you look at the standard deviation, right, across the MOS range, you typically have a pretty increased variety, right? Obviously, because it's very clear. I mean, if you have an absolute category rating, right, you can respond 1 to 5, right? Then obviously you have more variability to get to a mid-level vote of 3 or something like this, right? And so people may actually be thinking more in the case that the decision is in the mid-range of this MOS, right? So I would be thinking it would be quite interesting to relate the response time also with where on the scale, for example, right, am I located? Maybe that comment has been made, and then
no, it hasn't. Thank you for this question. I think that, of course, we will need to probably think more on how to apply it in this more complex